In this video, we're going to be looking at solving logarithmic equations by converting them into exponential form. So for this first example, whenever you see log written by itself and there's no actual base written there, that's the common logarithm. And that's where it would be on your TI-84 plus as well. And the common logarithm means that the base is 10. So I'm just going to go ahead and write a 10 in there. Now, to convert it into exponential form, then what you have is the base raised to this power, okay, is equal to the argument. And the argument is everything inside the parentheses. Okay. Now, this is a quadratic, and I can solve a quadratic if it's equal to 0. So 10 to the first power is just 10. And then to make it equal to 0, I'm going to subtract 10 from both sides. So that gives us the equation x squared minus 3x minus 10 is equal to 0. Okay, now I can solve this for x either by using the quadratic formula, or I could just try to factor it. Are there two numbers that multiply together to give me negative 10, but at the same time they add up to give me negative 3? And yes, there are, negative 5 and positive 2. So I'm going to solve this by factoring, finding out what my x values are. You could have used quadratic formula if you don't like factoring. Now you can see here that the solutions, the zeros of this equation, are going to be x is 5 and x is negative 2, because that will make it 0. All right. Now we're not done. Before we go on, we have to make sure, are these allowed? And so what we do is we look at the original equation, and these have to be in the domain. So what does that mean? The x values have to be allowed. So this argument, what's inside the parentheses, must be a positive number. So you're going to have to check that the argument is a positive number, so it's strictly greater than 0. So let's see what happens if x is equal to 5. Then if I replace x with 5, I'm going to get 25 minus 15, which is 10, which is positive. So 5 is allowed. So one of my solutions is 5. Now what about negative 2? Is that allowed? Well, I'm going to put negative 2 into the argument. So wherever there's an x, you replace it with negative 2 in parentheses. Negative 2 all squared is positive 4, and then negative 3 times negative 2 is positive 6. So once again, if x is negative 2, my argument is a positive number, so it is also allowed. So you absolutely must check that your answers are allowed in the original equation. So my solutions are x equals negative 2 and 5, or sometimes books will just write a solution set like that. Okay. All right, so let's move on to the next problem. Let's see if we can solve this equation. Okay. Now, when you see ln, get that back up on the screen, that's the natural logarithm. And ln is the same thing as taking a logarithm at base e. Okay, so if you see log by itself, that's the same thing as taking a logarithm at base 10. So what I'm going to do is I'm going to go from this shorthand to the longhand, because you'll see in a minute. So ln is the logarithm of base e. And now to solve this, I'm going to convert it into exponential form. And the way I convert it into exponential form is it's the base raised to this power is equal to the argument. So whatever's inside the parentheses. Okay, so that becomes my new equation, which I'm going to rewrite over here in black. Now, if I'm going to solve this, I need to solve for the unknown, which is x. E is not an unknown. E is like pi. It's a fixed number. My unknown is x. So I need to solve this for x. So the first thing I might do to this equation, since I'm solving for x, I'd like to get it on the left-hand side. Let's just swap sides of this equation. Okay, and then I'm going to subtract 8 from both sides. And now to find out what x is, I'm going to divide both sides by -3. And so I get my exact answer. If you saw this in the back of the book, they'd probably move the negative sign out the front, which means you'd have to negate every term in the numerator, but this is a correct answer. That's my exact answer. Now, more often than not, you're asked to give an approximation. So if I were to say approximate this to 4 places, then what I'm going to do is I want e cubed. So let me get rid of that. Okay. So the numerator is e cubed, so I'm going to press the second button and the ln button, and that'll give me e to the power of, so 3, and then -8, and I'm going to press enter. That is my numerator, and then I'm going to have divided by -3. And so if I get an approximation, say to 4 decimal places, that's going to be 1, 2, 3, 4, and that 1 won't change anything, so I'm going to have that. All right, so you have an exact answer and you have an approximation. Okay. Oh, and before I go with that, is it allowed? So let's look at the approximation. Is this allowed? Now, some students will say, no, it's not allowed because it's a negative number. That is not how it works. If it's allowed, then the argument, what's inside the parentheses, must be positive. So I'm going to substitute x into there, my approximation. So if my approximation is allowed, then the exact answer will be allowed too. Now, the only thing we need to know here is when you multiply two negative numbers together, you get a positive number. So you're going to have 8 plus something, a positive number, and that's going to be greater than 0. And so it's going to be positive and it will be allowed. But if you want to be more precise, 8 minus 3 times -4.0285 gives me a positive number. Okay. So my argument is positive, so it is allowed. So that is the answer to that is yes. Okay, moving along. Let's see if we can find solutions to this. Now, If I am going to convert that into exponential form, I need to have a single logarithm on the left-hand side. So I need to put those together. And the way I put those together, under the rules, it's the logarithm properties or rules. It's going to be the first one, which is the product rule. And it says if you have the sum of two logarithms and they have the same base, which they do, then you can rewrite it as a single logarithm. And the way you do is it's going to be just the order that they come, this times this in the argument there. So I go from a sum of two logarithms to a single logarithm using the product rule. Now I'm going to convert this into exponential form. And the way you do that is it's the base raised to this power equals the argument. So that's going to be 36 is equal to, now I'm going to multiply that through, x squared minus 9x. And again, I can solve any quadratic if it's equal to 0. So if I subtract 36 from both sides, I'm going to have that. Okay. So let me come back here now and have that. Now, once again, I can solve that for x using the quadratic formula, or I can try and factor it. If you can factor it, I prefer to, because quadratic formula can be messy. Are there two numbers that multiply together to give you negative 36, but at the same time add up together to give you negative 9? And yes, there are. Negative 12 and positive 3. Negative 12 times 3 is negative 36. And negative 12 plus 3 is negative 9. So negative 12 and positive 3 is how I factor it. And now to solve it, what will make this 0? Well, if x is 12, that'll make that parenthesis 0, and then I have 0 times something else. So these are my zeros. But the question is, are they solutions of the original equation? So for the original equation, the arguments must be positive. So what's inside the parentheses has to be positive. So that's positive. And if x is 12, then 12 minus 9 is going to be 3, which is a positive number. So 12 is allowed. But now, if x is negative 3, you can see that's not going to be allowed because this argument, what's inside the parentheses, will not be positive. So negative 3 is called an extraneous solution. So negative 3 is extraneous, and you have to reject extraneous solutions. So my solution to the original problem is x is equal to 12, or the solution set is 12. You do not include extraneous solutions. Okay, let's keep going. Let me try and get that. Okay, now let's do this one. Again, if I'm going to solve this by converting it into exponential form, then I need to have a single logarithm on the left-hand side. And so I'm going to need to use a logarithm property, and the property I'm going to use now is the quotient rule, or the rule. And what the quotient rule says is if you have a difference of logarithms, and they have the same base, in this case they have the same base, so we can see the base is 10, you can rewrite that into a single logarithm, and the argument of my single logarithm is going to be a quotient. And so you take them as they come. This will be the numerator, and that will be the denominator. Okay. Again, since it's log by itself, we know that the base is 10. Now I can convert that into exponential form. So I'm going to have 10 to the first power is equal to the argument. So the argument is everything inside there. Okay, so let me write that out here. So 10 to the first power is just 10. Now, I want to solve this for x. I have a fraction here, a rational expression, with x in the numerator and denominator. So what do? Well, what we're going to do is we're going to get rid of the fraction. So I actually need to give myself more space here. How do you get rid of a fraction? You multiply both sides by whatever the denominator is. Okay, so by design now, the denominator is canceled there, and so I'm going to have x plus 25 over here. Now on this side I'm going to have 10 times 2x minus 7, so I'm going to go ahead and multiply the 10 through. 10 times 2x is 20x, and 10 times negative 7 is negative 70. Now I need to solve this for x. So I need to get x, everything with x on the left-hand side. So I'm going to subtract both sides by x. So that's gone. And then this does not have an x in it, so I'm going to get rid of that. I'm going to add 70 to both sides. So 20x minus x is 19x. And then 25 plus 70 is 95. And now to solve this for x, I am going to divide both sides by 19. So I come over here, and I'm going to have 95 divided by 19. Okay, so what I end up with is that x is equal to 5. So the 19's cancel here, and I'm left with 95 over 19, which is 5. Now, is it allowed? You must check that. You must, in the original equation. Now, in the original equation, all of the arguments have to be positive. So x plus 25 has to be greater than 0, and 2x minus 7 must be greater than 0, must be positive numbers. So if x is 5, this becomes 5 plus 25, which is 30, which is a positive number. All right, so far so good. And if x is 5, then I have 10 minus 7, which is 3, which is also positive. So all of my arguments are positive, so this is allowed, and so that will be my answer. That is my solution to the original problem. Okay. Now, is that it? I think I went through everything. Lovely. So that concludes this video.